This video is on polynomials. The definition of a polynomial is an expression with constants, which are just numbers, variables, and exponents. Now, for this definition, the exponents must be whole numbers. Which means that it can have an exponent of 0, but they must be positive, and they must be whole numbers, so 0, 1, 2, 3, 4, so counting numbers. They can't include 0 because the exponent of 0 will change the value into a 1. So if it's 5x to the 0, that would be 5 times 1, which is just 5. Turns it into a constant. Because the exponents must be whole numbers, that means they cannot be negative, which means that there will be no variables in the denominators. If you have an exponent that is negative, the variable will turn to become into the denominator, which we're not allowed to have. Some characteristics of polynomials is that it has two names. Polynomials are named by their degree, so that's the highest exponent, and the number of terms. So it has two names. Name it by its highest exponent and how many terms there are in the problem. An example of a polynomial that has constants, variables, and exponents can be 5x squared minus 3x plus 5y cubed minus 3. This is considered a polynomial because all of the exponents are whole numbers. It has no variables in the denominator, and it consists of constants, variables, exponents. It consists of all types of numbers and variables. The variables do not have to be the same. Now, if I were to name this using its characteristics, I would need to find it by the degree, which is the highest value of the exponent. This has an exponent of 2, an exponent of 1, an exponent of 3, has an x value with an exponent of 0, meaning that it will be x to the 0 is equal to 1, and that'd be negative 3 times 1. So if I were to name this, I'm going to have to use this largest exponent of 3, which would actually give us the name of a cubic, and this is a cubic polynomial. Right now, I'm only going to name this for the polynomial itself. There are 1, 2, 3, 4 terms in here, so it's be considered a polynomial of 4 terms. Another example of a polynomial could be 17m squared minus 3m plus 11. There are no denominators, there are no variables in the denominator, and our exponents are all whole numbers. This one has the highest exponent of a 2. This would be considered a quadratic polynomial. And in this case, since there are 1, 2, 3 terms, this would be considered a trinomial. Nomial means term, so there are 3 terms, trinomial. We could also have 3a to the 4th plus 2a squared, which has no variables in the denominator, and our exponents are all whole numbers. So we have the highest exponent is a 4. This has a name of a quartic. And then since there are 2 terms, because I cannot combine these because this is an a to the 4th and this is an a squared, there are 2 terms, which is called a binomial. Another example we can have is 1208 x to the 5th. This is considered a polynomial because it has constants, it has numbers, it has variables. All the exponents are whole numbers, and there are no variables in the denominator. This one has the highest exponent of 5, which has a name of quintic. And there is only one term because there's no addition or subtraction in here. It's a monomial. Quintic monomial. A non-example, or examples that are not polynomials, could be 2y divided by x. Because there's a variable in the denominator, we cannot call this a polynomial. We might also have 5x raised to the 1/2. 1/2 is not a whole number, so because it is a fraction, this is not a polynomial. We might have x plus y to the -2. And again, our exponent is not a whole number because it is negative, therefore this is not a polynomial. Might have 8m squared, all of that divided by 3n. This has a variable in the denominator, therefore it is not a polynomial. You can have fractions as your numbers as long as they are your coefficients or your constants. You cannot have a fraction in an exponent, and you cannot have a variable in the denominator of your fraction. So classifying the polynomials goes with the characteristics. We want to name them by their degree and their number of terms. So the degree is for any one variable polynomial. The degree is the largest exponent for that variable. This is if it has only one variable. So if it's just 5x, it would be the one that has the largest degree. However, you might have some terms that have, I'm going to make a little note of here, that have multiple variables. So we might have 5x squared yw. This has more than one variable. This does not follow that it's the largest exponent for that variable. This has an exponent of 2, an exponent of 1, and an exponent of 1 on all of your variables. That means that the largest exponent, or the degree of this problem, would be 2 plus 1 plus 1. We would have a degree of 4 for this problem because we have all of the variables are connected to the same coefficient. This is all in one term. So we would add up all of the exponents for this one term. Not all of the terms in the problem, just this one term. This example, the definition of the degree goes for it if it has just one variable in the problem. So for right now, we're going to focus on just one variable. We're having one variable on each term. So when we classify them, the degree, we can have a 0 degree, a 1 degree, a degree of 1, a degree of 2, a degree of 3, a degree of 4, a degree of 5, and then after that, so anything 6 or more doesn't have a special name, but 0 through 5 all have a very special name for it. If it has a degree of 0, so x to the 0 becomes 1. That means that this is actually a constant. An example of this is 3x to the 0. The exponent is attached to only the x, so this becomes 3 times 1, which is just 3. This is why it becomes a constant. If you have a degree of 1, the name of that is called a linear polynomial. A linear polynomial you'll see as maybe 2x, but you'll see it with so maybe 2x plus 1. You'll see it without an exponent here, but know that the exponent is a 1, because we don't normally see an exponent of 1 on problems. We just know that it's there. If it has a degree of 2, so the highest exponent is 2, it is called a quadratic. An example that you might see for this is x squared plus 4x. And even though there are multiple terms here, we look at the highest degree on this term, which is x squared, and then the degree on this term, which is just a 1. So the highest one is 2, which is why it's called a quadratic. We do not add the exponents together. A term with a 3 as your degree is called a cubic. An example that we might see here would be y cubed minus y squared plus 3. Again, we only have one variable on each, so this has an exponent of 3, this variable has an exponent of 2, and this variable would technically have an exponent of 0. So our highest exponent here is a 3, which is why it's a cubic. A fourth degree is called a quartic. If you remember, there are 4 quarts in a gallon. An example we might see for this would be m to the 4th minus 3m squared minus 1. So again, we only have one variable in each of the terms. So we would look for the one with the highest degree, which is a 4, and this is why it would be a quartic. A fifth degree, a degree with 5, would be called a quintic. An example of this might be x to the 5th minus x squared. Again, we have just one variable in each of our terms. So our exponent is 5, our exponent is 2. The higher number is 5, so this is a quintic. Anytime you get to 6 or more, we just call it the number th degree. So it might be called the 6th degree. It might be called the 7th degree. It doesn't have a special name. We will just call it the number with the th degree, like it's place, 10th place, so 10th degree. An example that we could see here when we would look at it would be maybe z to the 6th plus 4. We only have one variable in each of the one type of variable in each of the terms. The highest degree here is a 6, so this would be called a 6th degree polynomial. So this is how we name it by its degrees. So this would almost be like its first name. So to classify it by number of terms, we would use the terms nomial. So terms are separated by a plus or minus. So we're either going to be adding or subtracting. Terms are not separated by multiplication. If it's multiplied, it's actually still in the same term. Now, the types of terms we can have is we can have 1 term, 2 term, 3 term, or we can have 4 or more. Because each of these have 1, 2, and 3 have a special name. The special name for a 1 term is called a monomial. What this looks like, it has 1 term, there's no addition, no subtraction. It could be just one number, or it could be a whole bunch of numbers with variables, but there's no addition or subtraction. So an example of that would be 25xy. This is all 1 term because there's no addition or subtraction. So we would underline, if we were trying to figure it out, we would underline that there is no addition, subtraction. This is 1 big term. 2 terms is called a binomial. That means that we have 2 terms split up between a plus sign or a minus sign. So an example of this would be x squared plus 1. We have a plus sign here, so we have 1 term here is x squared, and our second term is 1. 3 terms is called a trinomial. An example of this would be 3x squared plus 4x minus 5. We have pluses and minuses. So if I underline starting with the first number to a plus sign, that's 1 term. Starting over again, that's the second term. Starting over again, this is our third term. We have 1, 2, 3 terms, which is why it's called a trinomial. Anytime we have more than 3 terms, we call this a polynomial of however many terms there are. So this would be considered a polynomial of, and then we would say how many numbers there are. So of 5 terms, of 7 terms, of 4 terms. So a polynomial of however many numbers there are terms. Y cubed minus y squared plus 2y plus 5. Because I cannot combine any of these terms, this is a cube, square, linear, and constant, I do not have a way to combine them. So I figure out how many terms there are. I have a number or a variable until a minus sign, that's 1. Then I have another one, that's 2. Then plus sign, 3. Then another plus sign, 4. This is called a polynomial of 4 terms. I would write this out as polynomial of 4 terms. So to do a couple of examples, we're going to classify each by degree and number of terms. So we need to combine anything that we can. Then we need to actually determine what the highest exponent is and how many terms there are. So in question 1, we have -7 plus 3n squared. We will not want to actually rewrite this in standard form to have our highest exponent first. Our n squared has the highest exponent, so this entire term will be written first. This is a positive 3n squared, and then we have a -7. This is how we write this in standard form. So now we can determine how many terms there are and what the highest degree is. The highest degree, or the highest exponent, is a 2, so it will be called a quadratic, and there are 1, 2 terms. So this is called a quadratic binomial. A quadratic binomial, because our largest exponent is 2, and there are 2 terms in the problem. On question 2, we have the number 5. This is in standard form because we have nothing else needs to attach to it. So there is 1 term. So we know that this is going to be a monomial. But if we come over here, this has no variable attached to it. There's no multiplication of a variable. So this is a constant. This would be considered a constant monomial. A constant monomial. And on question 3, we want to see if we can combine anything. We have an x squared, an x to the 4th, and no x. We are not able to combine anything. So if we were to put this in standard form, meaning our highest exponents go in order. So our highest exponent is a 4. So we want to put this entire term first. This entire term is a negative x to the 4th. Then we would want to put the next exponent, which is an x squared, so that's entire positive 3x squared. And then we have a -11. This is now standard form. So again, our highest exponent is still the 4, so we would call this, where the degree is a quartic. And then there are 1, 2, 3 terms. This is called a quartic trinomial. And this is how we classify by degree and number of terms.